You ever wondered why apps crash during ticket booking for a big movie or concert? The answer is often one hidden problem in backend system. Catch stamped. And today I will show you how we solve it using distributed single flight locking. Imagine your application has 10 server running in production and suddenly catch expires. At the exact same moment, 100 users hit your API. How many external API call happen? You may think just one. Wrong. It could be 10, 50, even 100 duplicate API calls, and that can crash your downstream system. Today I will explain how we solve this using something called distributed single flight locking in our production microservice. So imagine this: a new Marvel movie ticket booking opens at exactly 10 a.m. 10,000 people are refreshing Book My Show, waiting to book tickets. At 10 a.m. sharp, everyone click refresh. Now imagine Book My Show does not handle this smartly. Instead of one system fetching seat availability and sharing it, every single user request directly hits the ticketing system. What happened? Server overloaded, massive delay, possible crashes. Now imagine a smarter system. First, request checks seats availability, then fetch fresh data, and then store it. Everyone else reads the same data, much faster and much smarter. That is exactly what single flight locking does. In software, this happens during catch expiry. I'm just giving one example. Suppose Redis catch TTL is 5 minutes and catch expires. Suddenly many requests come without protection. Request 1 call the external API. Request 2 also call the external API. Request 3 it's also called the external API. Request 4 it's also called the external API. All are calling same API. This problem is called thunder in heart problem. And it becomes dangerous when external API is slow, third-party API has rate limits, API cost is high. In our project, we integrated with DVD event API. Main API included DVD event listing and DVD event details. To improve performance, we added Redis caching. Event listing catch detail we set for 5 minutes and event details catch detail we set for 5 minutes. During normal traffic, catch works great, but there was a hidden problem. When catch expires, multiple Azure function instances can call DVD API at the same time. I'm just giving example. Instance 1 calling the DVD event listing API. Instance 2, many more user also call the DVD event listing API. Instance 3, from there also it's calling DVD event listing API. All calling the same API simultaneously. That creates unnecessary load in DVD system. So without lock, what will happen? If there is a 10 requests, let's example, then 10 DVD API calls, and what will happen? Traffic spikes. As a result, possible timeout or rate limit. And what will happen if we use with distributed single flight? On that case, 10 requests, but in this case, one request gets locked. DVD API calling, then request, other 9 requests, all are waiting, and catch updated. Then what will happen? All 10 requests get the same data from the caching. So what is the benefit section after implementation? So what I want to say, why normal in-memory lock was not enough. At first we used in-memory locking actually, but what happened in this case? This works only inside one server. Good for same instance request, but it is not good for the multiple server. It's very bad for multiple server instance. Example, suppose server A has lock, but server B does not know that server A has already lock. Server C also does not know. So duplicate call is still happen. So what is the solution? So the solution is distributed single flight lock. There is a where distributed lock comes in. instead of just local memory, we use Redis itself to manage locks. In this case, what will be the flow? When cache will expire, all the requests will come. Try acquiring the Redis lock. Set lock key value nx ex for expiry 15. So what is the meaning of set lock key value nx ex 15? Meaning set lock only if not exist, then expire in 15 second. So flow in simple way, if we talk about, then lock acquire, request A gets lock, so call DCT API, get fresh data, save in Redis cache and release the lock. Done. So lock not acquired for case 2, then request B comes, Redis says lock already taken, so request B waits. It keeps checking constantly the Redis data. Has fresh cache arrived? Once cache is available, then only return data. No external API call needed. Beautiful. Visual example if I want to give you, then just imagine that without lock 10 request 10 DCD API call, but with lock 10 request but 1 lock winner and DCD API call, request wait, all get. As a result, what will happen? 10 API call reduced to 1. So no needed for 10 separate API call. We implemented this in DVD service, get listing and get event details using Nest.js, Azure function, Redis, IO Redis. Lock configuration, lock TTL 15 seconds, wait timeout 10 seconds. And environment variable, we are using DVD catch lock TTL seconds for 15 and DVD catch lock wait timeout for 10,000. This gives the cross instance protection. Fallback safety, if we talking about, what if lock holder crashes? It's a very good question. So we use TTL. So even if server dies, lock auto expires after 15 seconds. So no deadlock. This is why Redis lock is powerful. And what is the benefit after implementation? So first benefit is reduce duplicate DVD API call, lower traffic to DVD system. Third, better scalability during traffic spikes. Fourth, faster response time. Fifth, reduced API cost. And sixth, improved system reliability. So if your system has cache, multiple server and then external API, then Redis cache alone is not enough. You also need distributed single flight locking. This small optimization can save your system from massive traffic spike. So if this helped you understand distribution locking better, like this video and subscribe and comment below. Have you ever faced cache stamped or thundering hard problem in production? Write in reply. I will check every comment and response back. Thank you. Bye bye.